Hey guys, it's Solbyte, and today I'm going to be going over Doubly Linked List. So far we've only gone over a singly linked list, which is basically a linked list that has two things, right? As we've discussed in my linked list videos, we know that linked list, every element of a linked list or a node of a linked list has two things. It has the value or the actual data of that linked list, and it also has a pointer pointing to the next node in that linked list. Now, a doubly linked list is a pretty easy concept if you understand a singly linked list. And essentially the main difference is that a doubly linked list has two pointers instead of just one. So each node will actually have three things inside of it. It'll have the value or the actual data of that node, as well as a pointer pointing to the next node in that linked list, as well as a pointer pointing to the previous node in that linked list. So obviously, I've already discussed that linked list kind of take up a little bit more memory. So in terms of memory, a doubly linked list is even worse, but there's plenty of situations where you may want to have a doubly linked list if you want to traverse both forward and backward through the list. And today we're actually going to be doing that just to kind of show how it works. And yeah, so let's go ahead and kind of get into it. So in my first linked list video, I created a struct node. I'm going to do a class node today. I did a class node in my last video as well, where I went over insertion, deletion, and traversal through a singly linked list. So make sure to go watch that as well if you want to kind of understand a little bit more, a little bit more of how linked list kind of works. Because that video really kind of encapsulates the logic that goes behind a linked list. So anyway, so we're going to create a class node, and let's go ahead and do the access modifier public. So let's go ahead and create the value. All right, we'll just do an integer. And next we will do the normal node pointer pointing to the next node, and then we're going to create another node pointer pointing to the previous node. All right, so this is really the only difference between a singly linked list and a doubly linked list. All right, so we have this previous node this previous node pointer that allows us to point to the previous element in the list. So yeah, let's go ahead and go down here now and actually create this list using this node. And actually, let's create a constructor while I'm doing this as well, just so that way we can have a little bit of an easier time creating it. So let's set the value equal to n here, and let's actually go ahead and set next equal to a null pointer, and we'll do the exact same thing for the previous pointer. So perfect. So now let's go down here and actually create the list. So we're going to do the first one, which is going to be a node pointer to the head. All right, we're going to do a new node, and we're going to set the value equal to 10. All right, and now let's do, let's do like 4. Yeah, 4 is good. 4 kind of is enough to understand. So we'll just do 10, 20, 30, and 40 for these nodes here. And let's go ahead and rename these. We'll do second, third, just a very similar example to my first video, but that's okay. So, all right, perfect. So now we have the list, and now let's actually kind of set these pointers to the correct ones. So let's go ahead and set the head next pointer equal to the second node, and then for the second node, we will set the previous pointer equal to the head node. So this previous pointer in the second node is now pointing to the head node. So we can reference the head node from the second node without, having to directly reference, the head node. So that's pretty cool. And then we'll go ahead and do the same thing for next. We'll set it equal to third. We'll go down here and do the same thing for third. Set the previous pointer equal to the second node. All right. And then for the next pointer for that, we're going to do the tail. And now finally on the tail node, we will just simply do the previous pointer equaling the third node, and we don't need to do anything for the next pointer because we we don't, this is the end. So anyways, perfect. So we now have an actual linked list, and now let's go ahead and traverse through the linked list both forward and backwards, showing how we can utilize a doubly linked list. So first, it's going to just create what we already know. We're going to do the print list forward. We've done this before. So we're going to pass in a node pointer and just name it node, I guess. All right, and if you guys haven't seen me do the traversal yet, it's pretty simple. We just do a while loop, and in this while loop, we check if the node is a null pointer, and if it is, then it will not execute. So we just wait until this condition is met, and then when it is, then it'll stop. So for whenever it isn't a null pointer, we should be traversing through the list. So how do we do this? Well, first off, let's go ahead and just print the node value, right? And do a little indel there. And then now let's actually traverse. So we're traversing forward. So we want to set the node equal to the next node. So we'll just do it like this. So pretty simple. We've already done this before in my previous videos if you guys want to go and watch. But yeah, this is basically how we traverse through a linked list. And now it's going to do the exact same thing, but this time utilizing the, not forward. Now let's actually utilize the new element, or sorry, the new node pointer for the doubly linked list, the previous pointer. And we're going to use the previous pointer to to traverse backwards through the list. All right, so let's go to do this kind of the same thing here. And same logic for the while loop. We're just going to check if it is a null PTR, and then same thing, just print the values, so that way we can see it actually being printed out. And now all we have to do is just set the, oh, oops, my bad. All right, yeah, so now all we have to do is set the node equal to the previous node. All right, so pretty simple, pretty simple. So now let's actually kind of go ahead and test this. So we're going to print it forward first. We'll do print list forward. All right, we'll just pass in the head node. And it is worth mentioning that, of course, I'm creating these functions that should take in either the head node or the tail node. If this got the head node, we'd probably run into some errors. So we need to, I mean, for a more fleshed out program in the future, I'd probably add some checks here to see if the first node points to a null pointer, in which case it would just return. So, but I mean, right now, of course, just for this example, we're just going over how a doubly linked list works. I'm just kind of putting that out there, so that way you guys don't run into any problems yourselves. So we're going to do print list backwards, and we'll start here from the tail node. All right, and I'm going to do a cout right here as well, just kind of stating that it is backwards. All right, and we'll do another little cout here, just to kind of organize things, do forward for this one. There we go, perfect. All right, so yeah, let's go ahead and test this out. So just going to go ahead and compile and run it, and here we see forward, we get 10, 20, 30, and 40. And then for the backwards traversal, we get 40, 30, 20, and 10. So that's perfect. So yeah, that's kind of really it for doubly linked list. I mean, traversing, insertion, and deletion are pretty similar in regards to a doubly linked list. And in my next video, I'm going to be going over a circular linked list. Those are pretty simple as well, so don't expect the video to be too long on that one either. So yeah, doubly linked lists are incredibly useful, but they do use up a lot more memory because you are now storing 3 things in every single node. So it is worth mentioning that if memory is a concern, then you might want to avoid using a doubly linked list if you can, but still, with the modern day and age, maybe you'll be okay. Who knows? But yeah, anyways, if you guys have any questions, please let me know down in the comments below. And of course, as always, I'm going to leave some references to some other resources in the description in case you guys want to look a little bit further into Doubly Linked List. And that's about it. So thank you for watching.